Greetings students. Today we are going to start Unit C of Tier 2, Factors and Multiples. Now I have divided the chapter into 3 parts. This is the first part of those 3 parts. This is for class 6. The subject is Mathematics. I am Sibasis Sandilya and I welcome you to today's class. So the subtopics that we are going to discuss in this chapter are sorting prime number and composite numbers, finding twin prime numbers, finding prime factors using factor tree, and divisibility tests. Divisibility tests of 4, 7, 8 and 25, writing multiples, finding LCM and HCF of 2 or 3 numbers by prime factorization and division method, solving problems based on LCM and HCF, solving problems using relation between LCM and HCF. Now in this part of the video I am going to discuss all the theory parts and going to discuss the first few modules of the chapter, and we will discuss the later part, the other modules, in the subsequent videos. So let's get started. First of all, prime, composite and twin prime numbers. So till now you have already studied in the last year that what are prime and composite numbers. Prime numbers are those which are divisible only by itself and 1. And composite numbers are those which are divisible by itself, divisible by 1 and some other numbers also. Pause the video, read the definition of prime and composite numbers. It is very easy, you have already known these type of things. And look at the twin primes at the lowest part of the slide. These are pairs of prime numbers that differ only by 2. That means, let us take an example. 3 is a prime number, 5 is a prime number. 5 minus 3 is 2. That means 3 and 5 both are primes that differ by 2. That means 2 steps. Therefore 3 and 5 will be called twin primes. Prime factors and prime factorization. All the factors of a number which are prime numbers are called prime factors. The process of writing a composite number as a product of prime factors is called prime factorization. So when in exam it comes like find the prime factorization of such and such number, so we have to take out the prime factors and write the number as a multiple of those prime factors. That is how prime factorization works. Tests of divisibility. There are tests of divisibility of numbers by 2, 4, 5, 8 and 10, wherein a simple examining of n digits help one to make out whether or not the given number is divisible by these numbers. For example, if the last digit of a number is a even, therefore it will be divisible by 2. If the last digit is 0, then it will be divisible by 10. And if the last digit is either 0 or 5, then the number will be divisible by 5 and so on. So these are the tests of divisibility. The test of divisibility helps us to tell whether a number will be divisible by a certain number or not. Divisibility test of 2, 3, 5, 9 and 11. If the digits at the ones place is 2, 4, 6, 8 or 0, that means if the digits at one place is even, then the number is divisible by 2. If the digit at the ones place is 0 or 5, then the number is divisible by 5, as I already told you. Now, a number is divisible by 3 if the sum of all the digits is a multiple of 3. That means let us consider the number 12, 1, 2. So 1 plus 2 equal to 3. So 3 is divisible by 3. Therefore 12 is divisible by 3. And if the sum of all the digits is divisible by 9, then the number is also divisible by 9. Now, to test whether a number is divisible by 11 or not, let us follow the following given steps. It is a little bit longer than the other numbers, but still it is not that difficult. Once you understand, it will be very easy. Find the sum of alternate digits of the number. Subtract the smaller answer from the bigger one. If the answer is a multiple of 11, then the original number is divisible by 11. That means here we are considering the number 83567. Now, what we will do, we will add the alternative numbers separately. That means consider 7 as 1 place, 6 as 2, 5 as 3, 3 as 4 and 8 as the fifth position. So we will add the ones, third and fifth position numbers. That means 7 plus 5 plus 8 will give us 20, and we will separately add the even numbers. That means the second position and the fourth position. That means 6 plus 3 gives us 9. Now we will subtract 9 from 20. We will get 11, and since 11 is divisible by 11, therefore 83,567 is also divisible by 11. Pause the video, read the demo once again. If you still have doubt, contact me, call me after the class. I will help you out. For a divisibility of 7, we take out the number at the ones place, double it, subtract it from the other numbers and continue the process. If the resulting at the last is divisible by 7, then the number is divisible by 7. Here we are considering the number 39,886. The ones place is 6. Separate out 6, multiply by 2, it will give 12. And the remaining digits are 3988. We will subtract 12 from 3988. We will get 3,976. Again the last digit is 6. Separate it out, double it, it will become 12. Then we will subtract 12 from the remaining digits, that is 397. We will get 385. The last digit is 5. Separate it, double it, we will get 10. Subtract it from the other numbers, that is the 38 minus 10 will give you 28. Now 28 is divisible by 7. So the original number, that is 39,886, is divisible by 7. Pause the video, go through the steps once again, try to understand this properly. Generally most of the students have doubts in the divisibility tests of 7 and 11. So make sure you don't have any doubt in the divisibility test of 7 and 11. The others are very easy. These are the only two, the tests of 7 and test of 11, which has certain steps attached to it. So try to understand the steps, try to understand how to do this properly, because this type of things you will require it till your matriculation. So what are multiples? A multiple of a number is that number which is obtained on multiplying the number by a counting number. The first multiple of any number is the number itself, because when we multiply the number by 1, we get the same number. Therefore, 4 into 3 is 12. That means 4 multiplied by the counting number 3 is 12. So 12 is a multiple of 4. 12 is a multiple of 4. Again, 5 into 2 equal to 10. That means 5 multiplied by a counting number 2 gives you 10. So 10 is a multiple of 5. Lowest common multiple. The lowest common multiple, also called as the LCM of two or more numbers, is the smallest number which is divisible by each of these numbers exactly. The lowest common multiple LCM of 2 and 3 is 6. Therefore, the 6 is the smallest number which is completely divisible both by 3 and 2. So, 6 is the LCM of 2 and 3. In the same way, we have the HCF, the highest common factor. The highest common factor of two or more numbers is the highest number which divides each of these numbers exactly. For example, the HCF of 12 and 18 is 6. Since 6 is the largest number that can divide both 12 and 18, therefore 6 is the HCF of 12 and 18. Pause the video, try to understand all the three terms, the multiples, LCM at the HCF. Okay, now let us move on to module number 1. Sort as prime or composite. So all you need to do is mention that the given number is a prime number or a composite number. Look at the demo. 159. 159 is a composite number since it is divisible by 3. And what was the divisibility test for 3? 9 plus 5 plus 1 gives you 15. 15 is divisible by 3, so 159 is divisible by 3. And since 159 is divisible by itself and 1 and also by 3, so it is not a prime number, it is a composite number. Number 2, 269 is a prime number since it is not divisible by any number less than it. Hint: check if the number is completely divisible by any of the following prime numbers: 2, 3, 5, 7, 11, 13, 17 and 19. Now pause the video for 5 minutes and do all the problems given in module number 1. Now before going to the answers, let us discuss module number 2. Find all the twin prime. Look at the demo between 1 and 20. So we have to find all the twin prime numbers between 1 and 20. So first of all, we will write all the numbers from 1 to 20 in a tabular form. Okay. Now we will cross out all the composite numbers. So 4, 6, 8, 9, 10, 12, 14, 15, 16, 18 and 20. These are composites, so we are crossing them off. Now take pair of prime numbers having only one composite number in between. That means 3 and 5. It has only one composite number between them. 5 and 7 has only one composite number between them. 11 and 13 has only one composite number between them. Again, 17 and 19 have only one composite number between them. So these are the twin primes. So your concluding sentence will be, the twin primes are, write the pairs in bracket separated by a comma. That means start the bracket 3, 5, close the bracket. In that form, you will write all the twin primes between the given two numbers in the question. So in the same way, pause the video for 5 minutes, and actually you will need more time than 5 minutes, and take around 15 to 20 minutes and solve all the 5 problems given in module number 2. Now let us move on to the answers. So these are the answers to module number 1 and module number 2's question number A and B. Please pause the video, note down the correct answers. These are the answers to question number C, D and E. Again, pause the video, note down the correct answers. Now in module number 3, we have to fill in the blanks. Number 1, the first prime number is 2, that is done for you. Question number 2, dash is the only even prime number. Number 3, there are dash twin primes between 1 to 100. Number 4, there are a total of dash prime numbers between 1 to 100. Number 5, there is only dash prime number between 91 to 100. Module 3, question number B. Express the following even numbers as sum of two prime numbers like 6 equal to 3 plus 3, 16 equal to 5 plus 11, like that. Pause the video, try to do this yourself. Question number C. Express 5 as a sum and difference of prime numbers, one of them being 2. Pause the video, try to do this yourself. Question number D. Find the prime numbers which remain prime even when the digits are reversed, like 13 and 31. 13 is a prime number if the digits are reversed. 31 is also a prime number. Like that, find other prime numbers which also remain prime number even when the digits are reversed. Question number E. Write 7 consecutive composite numbers in a row less than 100. Now module number 4. Write the following numbers as a product of prime factors by using the specified method. So, demo number 1, we have to prime factorize 64 using the factor tree. So, what is the factor tree? See, 64 is broken up into 2 into 32. Then again 2 into 2 into 16. Then again 16 is broken up into 2 into 8. So 64 is equal to 2 into 2 into 2 into 8. Again 8 is broken up and 64 is equal to 2 into 2 into 2 into 2 into 4. And finally that 4 is also broken up into 2 into 2. So the final answer will be 64 is equal to 2 into 2 into 2 into 2 into 2 into 2. That is the factor tree method. Now look at demo number 2. We have to factorize 75 using the test of divisibility. Now this is just like finding out the LCM. Okay, 75, the first prime number is 2, it is not divisible by 2. The next prime number is 3. Now 75 is divisible by 3. So 75 divided by 3 gives you 25. Now 25 is not divisible by 2, not divisible by 3. The next prime number is 5 and 25 is divisible by 5. So 25 divided by 5 gives you 5. Again 5 divided by 5 gives you 1. So 75 can be written as 3 into 5 into 5. In the same method, pause the video for 15 minutes, write the following numbers as a product of their prime factors using factor tree. So these are the answers to module number 3 and module number 4. I hope everyone did everything correctly. If anything was wrong, pause the video, note down the correct answers. Module number 5. Write the following numbers as a product of their prime factors using tests of divisibility. Here you have to do that LCM type of method that you have to do here. So pause the video for 10 minutes. Try to solve all the 4 problems. So these are the answers to module number 5. If you couldn't do any one of those, please pause the video, note down the correct answer. So module number 6, determine which of the following numbers are divisible by 4, 8 and 25. Now before going for the demo, Look at the right hand side of the screen, the remember box. Number 1, for 4 and 25, check the number formed by the last two digits. If it is divisible by 4, then the number is divisible by 4. If it is divisible by 25, then the number is divisible by 25. Number 2, for 8, check the divisibility of the number formed by the last three digits. If the number formed by the last three digits is divisible by 8, then the whole number is divisible by 8. Number 3, the numbers ending in 00 are divisible by 2, 4, 5, 10 and 25. Number 4, the number ending with 000 are divisible by 8 as well as with 2, 4, 5, 10 and 25. Now look at the demo part. Number 1, 76. 76 is an even number, so it is not divisible by 25. 76 divided by 4 gives you 19 and no remainder, so it is divisible by 4. 876, see, the original number was 2876. So at first, to find out the divisibility of 25, what we will consider the last two digits. The last two digits is 76, it is not divisible by 25, so 2876 is not divisible by 25. 76 is divisible by 4, so 2876 is divisible by 4. Now the last three digits, 876, if divided by 8, it gives 109 and 4 as remainder. So 2876 is not divisible by 8. So the concluding sentence you have to write like this: therefore 2876 is divisible by 4 but not by 8 and 25. In the same way, pause the video for 12 minutes. Try to solve all the 4 problems given in module number 6. So these are the first 3 answers of module number 6. Pause the video if your answer was wrong and note down the correct answers. If you still have doubt in any module, in any problem, please contact me. This is answer number D. Please note down the answer. So this brings us to the end of today's class. I hope everyone understood everything properly. If you didn't understand anything, you know my phone number. Call me after the class and we will discuss your problems. In our next class, we are going to discuss modules 7, 8, 9, 10, 11 and 12 of Unit C. At this time, I would like to remind you once again, please revise all the problems carefully several times. Don't keep your revision pending till the last date. With this note, I am Sivasis Sandilya signing out. Thank you everyone for watching the video.